We got the 3 trig equations taken care of, or 3 trig functions taken care of. We did a little bit of practice on how to solve that. You probably did that, or you should have done that last night on the homework. What we didn't get to, and I don't think any of these showed up on the homework, is what happens when we don't know any angles. Okay, so we go back to our standard 3, 4, 5 triangle that we used for the original answers, original examples to find sine and cosine and things like that. And we now want to use the sides, and maybe you're given all 3 sides, maybe you're not, to find the angle measures. And this is not too bad if we understand this idea of an inverse function. So let's say I find angle A. We really only need to do this once, because once I find angle A, how do I find angle P?
You just subtract
From?
90.
From 90. Or 180 if you want to do 90, blah, blah, blah. Okay. The process is the same we did yesterday. Everything is identical, except we need to introduce this idea of an inverse function, which I think I want to go to the next slide. Yeah. Okay, so the inverse function is just like the inverse functions that we have for other functions. So for instance, if your function is addition, what's the inverse function of addition? Subtraction. What's the inverse function of squaring? Square rooting. It's the function that undoes the original function. And these are above your sine, cosine, tangent buttons. Okay, take a look at your calculator. They look like this. This isn't a reciprocal. Remember, x to the negative 1 is the reciprocal. It's a way to represent the inverse function. Okay, and it undoes the function that it's the inverse of. So the inverse sine function will undo the sine function. Okay, so here's how we're going to do it. There's just one small step which I didn't include in the notes here. But we're going to set up the sine equation like we did yesterday, answering that series of questions. What side do we know? What side are we looking for? Which function uses those 2 sides? Set up your equation. And then yesterday we were solving. To go from this step to this step, I do a simple thing. Start with sine of A equals 4/5. I intentionally left a little bit of space there because I want to get A by itself. So how do I undo the sine function? I do the inverse sine function. Basic rule of algebra, whatever you do to one side of the equation, you have to do to the other side of the equation. What's the inverse sine of the sine of A? A, right. They cancel each other out and you get that. Then you have this bad boy, which you can type into your calculator and tell me what it's equal.
53.
Say again?
I got 53.13.
Somebody confirm?
Yeah.
53.13. And those are degrees. And then once we know that angle A, we can find B by doing 90 minus that answer. And therefore angle B would be equal to 36.87.
Yeah.
Okay, so it's not that big of a deal. Is that fairly easy?
Yeah.
Again, it still comes down to setting up your trig equation and then undoing whatever the function is you're dealing with. Question?
So could you do the same thing with like cosine A or tangent A? You just have to do the
The inverse function.
yeah, the inverse function for it. I couldn't think of the word. And then you'll get the angle measure.
Yep.
Okay.
So notice in this case my variable is the angle, so when I set that up I know I have to get rid of the sine because I want to get that by itself. If that's an angle measure and I'm missing one of these, then I have to do whatever it takes to solve for that variable. That's the stuff we did yesterday.
Yeah.
Okay. Get rid of this. Come over here. And yeah, oh, good. Okay, solve the triangle. Now, solve the triangle means when you're done, you know all 6 parts of the triangle. All 3 sides, all 3 angles. I would start by drawing a picture. You said lose the iPad. Question?
Wait, so how would you know what size which? Doesn't matter. Or what angles which? No?
Am I still waiting?
Oh, never mind.
Oh, okay. Yeah. What was your question? I wasn't listening. I was waiting.
Like, doesn't matter which side's which.
Oh, yeah. You gotta label your triangle correctly. Question?
Are the A and B supposed to be lowercase to represent sides?
Oh, they are. Why are they uppercase? Good catch. Oh, because I realized that. Yeah, we noticed that the other day, didn't I?
Yeah.
Or didn't we?
Oh.
That's right, but these should be lowercase. I don't know why they're uppercase. Sorry.
That makes sense. Okay.
Thank you, Tommy. That's huge.
Yeah.
Those should be lowercase a and b because they're
I
sides.
was looking at it, I was like, how do I solve?
Right, because 13 plus 18 plus 90 is not 180.
Yeah, I was
We're
looking
violating
at
the
it.
laws of
A and
geometry.
B are sides, but C is an angle. So you can just make up random, you just like make up random letters.
There we go.
Like do A, B, lowercase c, and then uppercase A, B, and
How do
C.
you wait for a triangle? Yeah.
A is across from A, B is across from B, C is across from C.
Oh, okay.
And by the way, there's a couple different ways to solve these problems depending on what you're best at and use what you're best at. So if you rock Pythagorean theorem, then use Pythagorean theorem to find C. We don't care. If you're getting this trig thing, then use trig to find C. C being the side C, also known as the hypotenuse.
No, so you have to keep A, B, and C as the angles, but then this is the middle. Like S, you're supposed to label it A, B, and C, but it's.
How long is this side?
18.
It's 13.
Which one, 13 or 18?
13.
13. Now, you may have drawn your triangle differently, put A over here and B over here, it doesn't matter, as long as the 13 is across from angle A and the 18 is across from angle B. I need to find three things. I need to find lowercase c, I need to find angle A, and I need to find angle B. And if you're crafty and you don't like this trig, you only have to use trig once. If you love this trig stuff, you can use trig 3 times to do it. It's up to you. And remember, try to only use given information, not calculated information to solve the problems. Are you taking notes in pink highlighter today, Matt?
Yeah.
Rock on.
So
Say it loud, say it proud.
we just trying to find C.
No, you're solving a triangle.
So turn the angle measures and the side, maybe.
Christian, what'd you find first?
I found capital A.
How?
I used tan, or
Tangent
tangent,
of A is equal to?
13 over 18.
Okay, then what?
I found lowercase c with,
Wait, hold on, let's finish this. How did you find A?
oh, I added, I found 46.23 for A.
But how?
Oh, I did tan minus 1.
Inverse tangent.
Yeah, and then
So take the inverse tangent of both sides. So that's gonna give me A, and then you did the inverse tangent of 13 divided by 18,
yeah,
and got what?
35.83.
Can somebody confirm?
Yes.
35.83. And those are degrees. Okay, good, then what? Where'd you go to from there?
I went for the hypotenuse,
Okay, how?
Pythagorean theorem.
Okay. 13 squared plus 18 squared equals lowercase c squared. C turned out to be,
22.20.
okay, square root of,
493.
I don't even want to try to simplify that. So let's go with the decimal equivalent. 22.20. 22.20. Don't know units on that, so we'll leave that alone. And then, question?
Do
Is
you-
not a good way to start a question.
Sorry. Do you have to put the 0 there? Because it's the same.
No.
Okay.
How'd you find B, Christian?
I added together A and C and then subtracted that from 180.
Beautiful. And got what?
54.16.
Nice. Let's give it up, huh? Good. Anybody do it differently? Good.
Solve for B first.
Okay. And then how'd you find A? Subtract from 180 or 90, okay. And did you use Pythagorean theorem for C?
Yeah.
How else could I have found C?
Would you have done sin b equals?
I'm sorry, what B?
Sine b.
Sine, that's what I thought you said, yeah.
Equals 18 over x. If
A
that's
C?
C.
Yeah,
C. Yeah.
one method.
Yeah, could have done that.
So you can do the sine of B is 18 over C. You could do the cosine of B is 13 over C. You could do the sine of A is 13 over C. You could do the cosine of C, or of A, sorry, is 8. So a lot of possibilities. Or just Pythagorean theorem. It's up to you. You'll get the same answer. The only difference is, if you use trig, you're not going to get that answer. You're not going to get a square root answer using trig. You'll just get the decimal value of 22.20, which is fine. Doesn't matter. Okay? Any problems? So hopefully the inverse function isn't that big of a deal, right? How about some input here, kids? No? We're good? Excellent. Let's see what else we got here. Let's try a word problem. Are we making any progress here?
I don't know where the 5.5 goes.
Ooh, good question. Where does the 5.5, how does that come into play?
Isn't that the second triangle?
Ivan?
Do you draw two triangles?
No.
I was thinking the proportion.
No.
Okay.
Too complicated.
Okay.
Yeah, this isn't like the notebook stuck in the eye problem.
Oh, okay.
It's just a straight up right triangle problem. So we just need to figure out how the 5.5 comes into play. Go ahead.
It doesn't.
It does.
Oh. I was like,
If I solve this problem and Kira solves a problem, we'd have to solve it differently because my eye is further off the ground than her eye.
Because I'm short.
Does that make sense? Obviously, from the look on your face, it doesn't. But Alyssa can help us out, I'm sure. What do you got?
Where do you start to base of the triangle 5.5 feet, like above the ground level?
Nice. Here I am. I've lost some weight. Come straight across. Go up to top of the flagpole. How big is that angle?
37.5.
37.5.
So you just subtract 5.5.
So I split the height of the flagpole into two distances, 5.5 and, I don't want to draw on my pretty flag, and this distance. What do you want to call that distance?
C, W, C.
W. Whoever just
Much.
said that.
W?
Yeah.
I'm okay with W.
So you're just, oh, okay, so you just add 5.5 to it.
Yeah. What, I'm missing a chunk of information here.
Base is
100.
Oh, I didn't see that, sorry. This is 100 feet. So we don't split it into two triangles, we split it into a triangle and a rectangle. Solve the triangle. Get an answer for W, and then add 5.5 to the answer. So if Kira and I are standing next to each other, looking up at the top of the flagpole, and the angle from my eye to the flagpole is 37.5, will her angle be higher or lower? In other words, would it be more than 37.5 or less than 37.5? It'd be more, correct. Okay. What function are you going to use here? Should we go through the process again?
Yes.
Okay, it's a right triangle. Okay, so we're assuming the flagpole is perpendicular to the ground. We're going to use the 37.5 degree angle. Let's talk about the W first. Is that adjacent, opposite, or hypotenuse? Opposite. And we know the bottom is 100. Is that adjacent or hypotenuse?
Adjacent.
What function uses opposite and adjacent?
Tangent.
Tangent. So the tangent of 37.5 is equal to W over 100 or 100 over W? W over 100, which is easier because we don't have the switcheroo going on there. So W would be equal to a hundo times the tangent of 37.5. So W is equal to 76.73, but I want to add 5.5 to that bad boy. And so the flagpole is 81.73 feet. Okay, that's a big flagpole. Problems? Got it? Good. Now, sometimes you won't be given this information about being 5.5 feet off the ground. And that, did I add wrong? Oh, I didn't add the 0.5, sorry. 82.83, you said? 2.3. Thank you, feet. I just added 5. If they don't give you the height of the person or the thing that you're talking about, then the assumption is that they're laying on the ground with their eyeball in the grass. And it's going right from the ground up, which is kind of weird, but it'll happen sometimes. Okay, yeah. Last one, find the value of x. Just real quick, down and dirty. Your answer is the complement of her answer. What'd you get?
I got this for this one, but then I got 58. Did I do it wrong?
I don't know. What do you got? You got nothing?
I got
What do you got?
53.32.
Still working. What do you got? 51.32. What do you got?
53.32.
53.32.
I got 32.2.
32.
Jesus Christ.
All right, let's go over this one, I think. Woo! Okay, so first of all, it's a right triangle, so we're good to go with right triangle trig. The 10, opposite, adjacent, or hypotenuse?
Adjacent.
Adjacent. 16. Okay, what function uses adjacent and hypotenuse?
Cosine.
Cosine. So the cosine of x is equal to, leave some space, 10 over 16. How do I get rid of the cosine? Inverse cosine, good. And then you got to do it to both sides. This is going to count. This. There we go. Have to count. And then put that in your calculator. Inverse cosine of 10 over 16.
51.32.
What'd you do wrong?
I don't know.
Did you use sine?
No.
Well-
Oh, I don't do tangent. I don't know what I was doing. I wrote cosine, but I wrote tangent.
I understand. That happens sometimes. Okay. How big is this angle?
That's
Right. Complements of each other, right? How would you find that side?
I just did that.
One, Pythagorean theorem. Two,
Plus 2.
Trig.
good.
Sine
You could use sine
of x.
You could use tangent.
You can use any of them.
You pretty much use any of the three. Yeah, so we're good. Okay, doke. Okay, wait, we're not done yet. Hold on. I want to ask you another question. What is the exact value? Exact value, so no calculator, of the sine of 30. This will be fun.
Wait, we can't use a calculator?
No, because the calculator won't give you the exact thing. I mean, you can plug in sine of 30, go ahead.
It gives you 0.5.
0.5, right, which is 1/2. Bad example. Let's try the sine of 60. Go ahead, type that in, see what you get.
It's 1.
1.
I got
It's 0.86.
Okay, good, that's a bit better example, yeah, because this is 1/2, you just, yeah, that's cheating, but, how do I find the exact answer for the sine of 60? And I'll tell you, these are gonna pop up in problems where you're asked for a trig value of a 30-degree angle, a 60-degree angle, or a 45-degree angle. That should be a clue. How am I gonna find the sine of 60 degrees?
Oh.
Yes, Tom?
Well, you know, I might be wrong. But, so, it has to be an exact value, which is like, well, what I did is I did the sine of 60, and you have 86602. And then I stored it for x, and then I did x squared. And then I got why? You need an exact value, right?
Well, why not take the square root?
Just
Well, why would I take the square root?
Well, why would you square it?
Like,
What happened when you squared it?
I got 0.75.
Not quite.
And what is that?
Never mind.
Okay. I applaud the effort. Tommy?
I got radical 3/2.
You did. Hey, what's a radical 3/2?
Yeah, how do you type that in?
It's a square root of 3/2. Square root of 3 close parentheses divided by 2.
0.22.
It's
enough.
8.6.
Yeah.
Close parentheses.
Oh,
Oh my god. It's correct.
It's
Yeah,
correct.
It's correct.
All right. This will be fun.
You get that.
Where did you get that?
So I made a 30, 60, 90 chart.
Oh, look at that. Uh-huh.
God.
That's
What?
smart.
How long's this side?
Made it 1.
How about we make it A? Okay. How long's this side?
B.
A radical 3, and this side? 2A.
Back to
Okay, so now we want the sine of 60 degrees. So we're using the 60-degree angle. Sine is opposite over hypotenuse. Opposite
Oh
over hypotenuse. Whoopsh, whoopsh. Oh, yeah.
Tommy, why are you so smart?
All right. What's the cosine of 45 degrees? This might be a bad example. Oh, no, this one's good. Those are good.
Thank you.
Oh my.
What'd you say, cosine?
Yeah, so it's right.
Where? Oh.
What's the answer?
What over?
1 over radical 2. What's the tangent of 45 degrees? What's that?
I did the sine. I got
Oh!
0.
Wait, did you hear what Matt just said? Go ahead.
I did the sine and I got the exact same thing.
Why would you do the sine though if I asked you for the cosine? You just feeling saucy?
No, I just didn't realize you said cosine.
Oh, okay. But you got the same thing?
Yeah.
Why?
I don't know.
It's because
Magic?
it's- It's a nice sauce.
I mean,
Ridiculously what?
opposite over hyper. Oh, because they're both A.
Yeah. What's a tangent of 45 degrees?
1,
Why?
because it's A over A.
That's A over A. Good. So some of these you can get from the calculator. Sine of 30 pops up in your calculator as 0.5, which is 1/2. Cosine of 60. Check that just to make sure I'm right. Cosine of 60, 1/2 also?
Yeah.
Yeah. Tangent of 45 will show up on your calculator. The others, though, you got to get from the general form. You have two ways to approach it. I like to go back to the general form and just cancel the A's, but what Tommy started saying was he just made this a random distance. Okay, what'd you say, 1? So instead of doing A, he said, okay, well, let's make this 1. Well, if that's 1, then this is going to be 1 square root of 3, and this is going to be 2. Okay, then take opposite over hypotenuse, square root of 3 over 2. Okay. Either way works. I like the A method better, but if you want to just, you can throw in you can make the A 74. I don't care. Then you get 74 square roots of 3 and 148. And then just make sure you simplify your fraction. Okay? So that's only going to happen when you ask for exact values of sine of 30, sine of 60, or sorry, 30, 60, and 45, because you can relate it back to the 30, 60, 90 triangle. Occasionally we might ask you for a 90-degree value, but we saw what happened when we started playing with the 90-degree angle. We got all kinds of weird stuff with errors and zeros and ones and things like that. Okay? Questions? We're good? Awesome. Delete this. Close this. We're done with number 2.
What's in 'em?
Move on to number 3. So find a partner / group and go over yesterday's homework. Now, if we don't have time to talk about that before the end of the period, it's fine. Do day 6 tonight. I'll unlock it, and then we'll do some damage control.